All right, use the equation or the graph to determine the length of the stretch for a mass of 1 gram. Graph the outcome on your graph. Okay, I'm going to go back to that equation that we just created. My mass is 1 gram, right? So we're going to do D equals 3 times 1, which is 3. So we have a stretch of 3 centimeters. So, and it said, go back and plot this on your picture. So 1, and obviously these little submarks are every 1, right? And these obviously look to be 3, 6, this would be 9, 12, 15, and so on, right? So 1, 3 would be right here. Okay. Use the equation or the graph to determine the length of the stretch for a mass of 7 grams. Then graph the outcome on your graph. Well, this time my mass is 7, so I'm going to plug in 7 for my mass, or my M, right? So we got 3 times 7, which is 21 centimeters. That's my stretch. So now I'm going to go back and put that over here. At 7, that would be here between 6 and 8, right? And 21 would be between 18 and 24. So it's going to be this point right here. Use the equation or the graph to determine the length of the stretch of a mass of 13 grams. Graph the outcome on your graph. So D equals 3 times 13. That's going to give me 39 centimeters. Well, 13 is going to be up here, over here, right, between 12 and 14. And 39 is halfway between 36 and 42. So I'm going to put 13 down here, and I'm going to put 39 over here. Number 14 says, what do you notice about the points that you graphed in items 11 through 13? Well, let's just recall. This was the first one that we did, right? Here. I did this one, and I added this one. So what do we notice? They would all lie on that same line, right? How could you represent the set of all the possible masses in corresponding stretches? Well, we could just simply connect the dots. To form that line. Now, earlier in the first particular example we did, we had discrete data, which means that they could not connect because we were talking about washers and there was no way to drop half of a washer in. Here, I can have zero point 0.5 grams. So it's okay for me to say that we have part mass where we have this line and it be continuous. It says, what is the y-intercept of the graph and what does it represent? Well, if I connected these dots with a line, right? I'm going to do that in pencil just to kind of show you. My y-intercept would be right here where it crosses the y-axis at 0, 0. So the y-intercept is 0, 0. What does that mean? Well, it means that the stretch, TCH. The stretch is 0 centimeters for 0 grams on the spring attached to the spring. So that means if nothing's hanging from the spring's not going to stretch any. It's just going to be its regular length. It says, what is a reasonable domain? Okay. Well, remember domain would be my mass in this case. It's my x values. And my input is the amount of mass that I have. Well, can mass be negative? No. But can it be partial? Can I have 0.5 grams? Yes. So we would say our domain is going to be m greater than or equal to 0. Because m represents mass, which cannot be negative. All right, on to your debriefing question.